This is how you can build a fun interactive game using Microbit and CreateAI. This is called Chuck a Duck. It functions kind of like Hot Potato, where we've trained a machine learning model to detect when our duck is flying through the air and play a sound accordingly. And then when you catch the duck, it randomly chooses a number between 1 and 3 to determine whether you were in or out of the game, like Hot Potato. It's a really cool way to show your kids how you can use a machine learning model in real life. It will allow them to create their own data samples, refine their data samples, learn about things like bias and other AI literacy topics, all while playing a really fun game and coding it all with Microbit and MakeCode. To get started with our Chuck a Duck Microbit CreateAI project, you may want to use some sort of stuffed animal or something that will hold your Microbit that you can toss around the room. Obviously, this is totally optional. If you don't have access to a stuffed animal or something similar, you can just do this by tossing the Microbit itself around the room, but it is nice to have something a little bit more secure just in case the Microbit is dropped during the activity. We are going to be using this crocheted duck, which has a nice little slot in the back where we can insert our Microbit into and then seal it up so we can toss this around the room for our activity. You will need access to at least one Microbit for this activity. If you have access to a second Microbit, we suggest using it. There is another way that we can expand and make this activity a little bit more advanced by using the radio function between these two Microbits, where we'll have one Microbit inside the duck and then another Microbit that will be acting as sort of the control center that will be relaying the sounds based on what's happening to our flying duck in the activity. You will also need a power source for your Microbit that will be inside of the duck. For this activity, we are going to be using the Charge for Microbit, which is a rechargeable power pack from Ford Education. Our Microbit just pops in place and then it will connect to the rechargeable power source, and then this whole thing will go inside of our duck. If you don't have access to a Charge power pack, you can totally just use the regular disposable battery pack that comes with your Microbit Go pack. This will work just as fine as well. And lastly, you will need a USB cord with a micro USB end to connect our Microbit to the computer. So the very first thing that we're going to do to get started is head to CreateAI. Once you head over to CreateAI, we're going to hit Get Started, and we are going to start a new session today. Once you open CreateAI in a new session, it will look sort of like this. Nothing will really be there because we need to connect to our Microbit and get it paired so we can start incorporating the XYZ accelerometer data of the Microbit, which is how we're going to build our machine learning model. To do that, we will connect one of our Microbits to the micro USB cord and then plug that USB cord into our computer. Once we're there, we'll hit Connect at the bottom. It will tell you what materials you need for this activity, but we know we have everything already, so we'll hit Next. Follow the instructions to pair our Microbit to the program here. It will download a program onto the Microbit here, which will allow us to connect via Bluetooth. So once it's downloaded, we can actually disconnect that Microbit from the computer. This is where you need your power pack. So depending on what power pack you're using, you will want to assemble your Microbit onto the power pack. Once you have your Microbit power pack hooked up and turned on, you will see the LEDs light up on the front. This LED pattern needs to match the pattern that's shown on the screen here, which in my case it does. We will hit Next. Now it's going to ask us to connect via Bluetooth. So we'll go through those pairing steps again, but this time we're connecting via Bluetooth so we can have a wireless connection from our Microbit and our battery pack. Once we are successfully hooked up, you will now see that we can see the XYZ accelerometer values of my physical Microbit at the bottom of the screen here. So as I turn the Microbit around, you can see how those values change. In our program window here at the top, you will see that it's asking us to input the name of an action. For our Chuck a Duck game, we are going to have two primary actions. One is going to be throwing the duck, and then one is going to be where we're catching and holding the duck. We are going to start with the catching and holding, or resting of the duck. So to start recording this action, we are going to say catching. Naming each action will just help keep things organized when we get over to MakeCode. If you'd like, you can change the icon for this. Let's change it to a smiley face. Now, to create our machine learning model, we need to actually record a series of samples. As you can see here, we have a red record button where if we press this, it's going to give us a screen where we can start recording our samples, like so. You can record the samples one at a time like that, but there are a couple other tricks. Let's delete this one by clicking the X here for now. If we hit the three little dots here off to the side of that red record button, we will see two additional options. So you can record 10 samples, each individually, so each sample has its own countdown, or you can record for 10 seconds straight. In this instance, because we are recording catching or the duck resting, sitting still, we are going to record for 10 seconds continuously. So to get prepared to record our samples, we're going to grab our duck friend or whatever you're going to be using for this activity. We are going to take our microbit and charge and insert it into the little pocket in our duck and close it up like so. So you want to perform your samples as accurately as possible to what your real activity is going to be like, and that's going to come really important in a second. Once you have your microbit in there, you can see we're still seeing our XYZ accelerometer values. We are going to record for 10 seconds continuously of our resting. So once I hit record here, it's going to give me a countdown, and I'm going to record. We're recording, and as you can see, I'm making slight little movements here because I'm not going to catch it perfectly upright every time. So slight little movements to record a series of different samples. I like to call this an upright catch. But when we're actually performing this activity, chances are when that duck is flying through the air, we're not going to be catching it completely upright, perfectly still every time. So this is where it's really important to have a variety of data samples to represent all of the different possible actions of how we could catch that duck. Because if I catch my duck upside down, my XYZ accelerometer values are going to be very different than if I catch my duck right side up, on this side, backwards, so on and so forth. So what we want to do here is now record an additional set of 10 samples where maybe I'm catching my duck upside down, like so. So we will go ahead and we'll say record for 10 seconds. This time I'll pretend I'm catching my duck upside down. Again, little tilts here just because I might not catch it exactly in the same position every time. And last one. Perfect. But we know I could catch the duck on the side. So let's record some samples of the duck being caught on the side. You can record as many or as few samples here as you would like, but once you start testing your game, you will find that the more samples you have, the more accurate a machine learning model will be. In fact, if you only record a few samples of doing this, you might find that the game is quite inaccurate or it's not responding the way that you think that it should, which is a really good learning opportunity because students might need to go back and reevaluate their samples and perhaps add more data samples to the model. Perfect. So as you can see here, we have a whole series of data samples. Each one of those colored lines represents one of the XYZ values. And as you can see, they're varying because depending on where I catch my duck and what orientation it is in space is going to change the way that those values are read. So these all look good. If you needed to delete one of these samples, you can just hit the X, but those all look good to me. So that is our catching. Next up, we need to actually add our throwing action. And in this case, let's change the icon to be a duck because that's appropriate. Now what we need to do, this is the fun part, this is where you need to record data samples of throwing your duck. So again, we are going to record these continuously because I want to be continuously throwing the duck constantly. So we will hit record for 10 seconds, we'll give a countdown, and then I'm going to start throwing my duck, throwing my duck, up, down. Don't stop because we don't want to record a resting sample. We want to just record throwing. So I'm recording, throwing my duck. Perfect. But again, that's only 10 samples. So you could move ahead with this and still have an effective activity, but the way that I was throwing it was almost always upright. So our upright catching and our upright throwing. But that's probably not how the students are going to throw the duck, especially if they get really into this game. So we are going to go ahead and record another 10-second sample, but this time I'm going to throw it upside down. Upside down duck. Maybe he does a little spin, flip around, more samples. Again, the more samples that you record here, the more accurate your model is going to be. Perfect. And let's just do one more set here for good measure. So start tossing, start going. Perfect. Almost there. 7, 8, 9, 10. Good. Perfect. Okay, so now when we take a look through our samples here, we can see they're all varying, which is good because we're going to have all sorts of different throws. Every person throws different. Somebody might throw a big throw, a small throw, upside down, whatever it is. We want to make sure that we have samples to represent each one of those potential throws that might happen in our game. Now that we've recorded our two main actions, which is catching and throwing in our Chuck-a-Duck game, we need to train our model. And training our model means that it is going to look at all of those samples, analyze them, and then recognize patterns, so when we're actually performing our game, it is able to predict which action is happening based on the data samples that it was trained on. So you can click this Train Model button here down at the bottom, and we're going to start training. So again, it's going to take a couple of moments to look at all the data samples and analyze them. Now you'll notice that the screen is changed, and we now have a percentage of certainty where the model is predicting what is happening. So right now my duck is resting, I'm not doing anything, or catching when it's not moving, and it is predicting that with 100% certainty. If I start tossing my duck, again, all sorts of different throws, you can see now my model is predicting that I'm throwing the duck, which I am, so that's good. If I catch the duck, you can see that our model now is predicting catching. And depending on how I catch the duck, because I've trained the model on all these different possible ways that I could catch the duck, it's predicting, even when I catch it upside down, sideways, whatever it is, that it is indeed catching, which is perfect. This is exactly what we want. You could stop here. This is a really great activity too for students to understand how a machine learning model is created. Maybe you need to go back and edit the data samples to add more samples, because maybe you didn't account for catching the duck upside down, so you could have students go through the process of adding additional data samples by clicking that Edit Data Samples button. You can go and record additional samples. You could also add other actions here if you want. Maybe you want to account for if somebody drops the duck in the middle of the game. You could record data samples to represent dropping the duck. Today, we're just going to stick with these two for the purposes of our game. So now that we have our model all trained and we've tested to make sure that it is accurately predicting the actions, we can now head over to MakeCode to actually code our Chuck-a-Duck game. We are going to hit this Edit in MakeCode button. That is going to take us over to the MakeCode window here, and you can now see that I have two input blocks by default, and each of these input blocks represents that machine learning model or the different actions that I trained. So on the first one, we have on machine learning catching, start, and it's the icon that I chose in the beginning, which means when it detects that catching, it's going to show the smiley face icon. And the second one, on machine learning throwing, start, show the icon of the duck that I chose. Again, you could stop here, download this to your microbit, and try this out. However, we want to take this game a little bit further by adding sounds that represent each one of these actions. So we'll set our duck friend aside for now, and we will start adding some additional blocks in MakeCode. So to add these sounds, let's first decide what we want to happen when the duck is thrown. I think that when the duck is thrown, we should play a cool sound or a melody to represent that duck flying through the air. So we'll head over to our music drawer, and we're going to say play melody. We're going to place that block inside our on machine learning throwing block, and we're going to say play melody. You can choose from the gallery here. And I'm going to choose this sort of ascending sound. So I'll click that ascending sound, and I think I want it to be a little bit faster because I want it to represent that the duck is moving fast. So you can change the BPMs here. Let's just change it up to something around 400. Perfect. That'll represent my duck flying. Now I need to add a sound to represent when my duck is caught. So we'll go back to the music drawer, and I'm going to say play just one tone, like so, when the duck is caught, to represent that the duck has stopped. Another little trick here is that you can add a block that says stop all sounds ahead of that play tone block when the duck is caught, because what we don't want to have happen is the duck is caught, but the other music hasn't finished, and now we can't hear if the tone has actually registered that the duck has been caught. So by saying stop all sounds first, then play our tone, we'll be able to hear more effectively that the duck has been caught. Now that we have both of these things added, we need to download this actual program onto that microbit that was inside of our duck. So we will go ahead and plug in our microbit back into MakeCode. We will hit download. You have an option here to say download it to the same microbit that we did the training on, or download it to a different microbit. In this case, we're going to download it to the same microbit because that's where we have our power and our charge and everything hooked up. So we'll follow the steps to pair again. it's going to download this program. Perfect. It's already going. I will unplug the microbit from the computer now. And as you can hear, it's detecting that I am resting, that we have caught the duck or caught the microbit, and so it's playing that tone. But to start testing this, I'm going to throw this microbit to test and see if it's registering that machine learning throwing block, and it's going to play our melody. And as you can see, it is playing our melody. So 2 other things that we can do to improve this program and the way that it functions in our game. First off, maybe when we are tossing that microbit or the duck around the room, we want that melody to play continuously through the whole time that the duck is flying through the air. Right now, when we toss it, it only plays until that melody is done, which is only a few notes, which is not very long. But in our program, we can say, play melody looping in background. So that means that the melody will continuously play for as long as that duck is flying through the air. So if we're tossing it to multiple people or somebody's throwing it really far, it will continue playing, which will just make our game better. One other thing that we'll want to do if we're changing this so the melody is looping in the background is add a little pause from the time that our duck is caught and all sound stops to when we play that tone to represent that the duck has been caught and is still. So we'll go to the basic drawer and we will say add applause block for let's do half a second, like so. Now we will plug in our microbit, download this improved code, and see how our game is. Okay, so now our tone will play continuously for as long as the duck is flying in the air. Perfect. So that melody is playing continuously now, which is just a way better way to play the game, so you always know when the duck is flying. And with that slight delay, we have time to catch the duck and for it to register that the duck has been caught and play that tone. Again, you could stop here. This is a really fun game to play in your class, but we can keep going. We can keep adding on. So this game is very similar to, say, a game like Hot Potato. So a way that we could build on this program to build something like a Hot Potato game, we can add a random variable to our game to say when that duck is caught, that tone that is played will be randomly selected and will decide whether you are still in the game or you are out of the game. So to build on our game to do something like this, we need to create a variable. So we're going to create a variable called duck. So we want to say when our duck is caught, we want to pick a random number to decide whether we are still in the game or not. So we are going to add this set duck to variable block here, and then we need to tell it what to set that variable to. So then we'll go to the math drawer. We will say pick random between 0 to 10. You could make this whatever chances you want. From our testing, we think that a good range is 0 to 3, which will give us a total of 4 options, which means that you have a 1 in 4 chance of being out of the game and a 3 in 4 chance of staying in the game. Next, we need to decide what actually happens when you're out of the game. So we will use a logic statement called if, then true, and also else. So you want to choose that second option there. We will add that block to our on machine learning catching input block. Next thing we want to do is choose a comparison statement. So this is going to compare the value of our variable. So we will add our duck variable in the left-hand side there. If that duck variable is equal to, this could be any of the options from 0 to 3. We can just leave it at 0 in this case. It doesn't really matter. It could be any number. We want to say what will happen in this case. So if we're saying 0 means you're out of the game, let's add some sort of sound that will represent being out of the game. So we will use this pre-canned melody block here, and we will change the melody to be this one here, which, as we'll hear in a second, will be an appropriate sound for being out of the game. Otherwise, if you are not out of the game and you are safe when you catch the duck, we will keep our previous block that says play tone for 1 beat, and that will represent being safe. We can keep this pause block, but we'll add it back up at the top here. That will just give our program a little bit of time to stop the sound, pause for half a second, and then decide what that variable is equal, and then play our new sound. Now that we have this all set up, we will download this program again onto our microbit, like so. And now we can give this updated program a test. So now that we have the new code downloaded onto the microbit, we can give it a test with our enhanced version of the game. So what should happen is when we toss our duck, we're going to hear that sound of our duck flying through the air. When we catch the microbit to catch the duck, it's going to randomly choose a number between 0, 1, 2, or 3. Depending on what number is chosen, we will either be out of the game or we will be safe and we can continue playing the game. So once we give this a toss, we'll see what happens. So we're flying and then I catch. So I'm safe. So we toss again. Safe. Safe. Safe again. So that would mean we were out of the game. So it's a 1 in 4 chance. You can adjust those chances to whatever you'd like. Once you have that code working, you can insert your microbit into your duck or whatever you happen to be using for this game, or just leaving the battery pack as it is. We can seal it up, and now we are ready to play our game. However, you might notice that now that our microbit is inside of our plushy duck, it is kind of hard to hear the sounds. So you can actually use the radio function between these two microbits to have this microbit radio to this microbit, and this microbit plays the sound while this duck is flying through the air. So let's go ahead and do that. So we'll need to have both microbits ready to go for this. And we'll start by modifying the existing code that we have here already. So what we want to happen is add a radio signal. So first we will need to say, on start, we need to set our radio group. If you happen to be doing this project with multiple different groups at the same time, you'll want to make sure that each group has their own radio group, which is basically a walkie-talkie channel. Since it's just me, I'll leave it as 1 for now. From here, we need to add a command to represent each one of our different scenarios in our game, which are throwing the duck, catching the duck and being out of the game, catching the duck and being safe. So what we will do is go to the radio drawer again. For this particular project, we are going to keep it simple. We are going to use the command called radio send number. I'm going to start by adding this block into the on machine learning throwing block. So when the duck is being thrown, I'm going to send the radio number 0. I'm going to repeat this process, and I'm going to say when the duck is caught and we're out of the game, that's going to be radio send number 1. And when we catch the duck and we're safe in the game, that's going to be radio send number 2. So each number represents one of those 3 possible scenarios in our game. I'm going to download this code onto the microbit, which is going to be inside of the duck. So we will say next, pair, and connect. Once that's downloaded, I can now take that microbit and put it back inside my duck because it's all ready to go. But now I need to connect my receiving microbit and add code so this microbit knows what to do when those radio commands are sent. So we will hook up this microbit, and we will actually go over here and open a new MakeCode program. So we'll say new project, and we'll say duck game. To start, I'm going to add that radio group to the onStart block and make sure that it's set to the same number that I used before. And now I need to add a block that says on radio received, and specifically a received number. So this is going to say when I receive a number through that radio channel, do whatever is inside of the block. In our particular case, we are going to use a logic statement that says if true, then else, to help us determine what happens depending on what number the radio receives. We are going to use a comparison statement, and then we are going to say received number equals 0. So this is the very first scenario, and if you recall back to our previous program, 0 represents the duck flying, so we want to match what was happening over here in terms of sound and LEDs with our receiving microbit so we can see what's happening and we can hear it better outside of the duck. So we will say on radio received equals 0. We want to show that icon, a smiley face to represent flying, and then we will also add in that same melody that we used before, which was that ascending. We had it set to 413 beats per minute. Otherwise, we're going to add a plus here. We want to say if radio received equals 1, And if we recall back, 1 is the scenario where we're out of the game. We want to then show an icon to represent being out of the game, which in this case, let's make it an X. And we want to play that pre-canned melody like so. And then lastly, we need to add another comparison statement to say if ready received equals 2. And 2 in our case represents being safe in the game. So we will add our icon and make it our duck. And we will play that tone that represents being safe. So we can get rid of that extra block there. And then we will download this onto this receiving microbit. Perfect. So once it's downloaded, this second microbit, the receiving microbit, you can hook up to another power source like a battery box or a charge, or you can just leave it connected to your computer just so it has power. Now we give it a test. So we will go ahead and grab our duck, and we can hear what's happening here is also happening on my receiving microbit. So when we throw our duck is flying. When we catch our duck, it's randomly choosing a number between 0 to 3 to determine whether we're in the game or we are out of the game. So that is how you can build a Chuck-a-Duck game that functions like hot potato. You're using a machine learning algorithm to determine when the duck is flying versus when it's caught. And then you're using MakeCode and the microbit to program what happens when each one of those actions or the machine learning model recognizes each one of those actions happening.